Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about FIR ideal low pass filter design with the frequency response. As previous classes we have seen this how this filter coefficient is computed. So plotting this, finding this integration and then substituting this value and truncating that and then finding the transfer function for the filter and making it as a realizable. Now we are going to find the frequency response for the filter things. So already we have find that this h of 0 to h of 10 up to all the filter coefficient. Now we are going to find this frequency response of the filter. So h bar of e power j omega will be given equal to n equal to 0 to n minus 1 by 2. So that will be 11 minus 1 by 2, that will be 5. So n equal to 0 to 5, a of n into cos omega n. So where we need to substitute these values. So we need to find this a of n and then we need to substitute. So for substituting that we have two formulas. One is a of 0. So this is applicable for only for an 0th coefficient. Remaining we have a of n. So a of 0 will be equal to h of n minus 1 by 2 and that will be, we can substitute n is 11, 11 minus 1 by 2. So this will be 5. So a of 0 equal to h of 5. So we know that h of 5, look at this tabulation. So h of 5 equal to 0.5. So a of 0 equal to 0.5. Now we can find for an a of n. So a of n is the formula is 2 into h of n minus 1 by 2 minus n. We need to substitute here and simplify this. So n minus 1 by 2, 11 minus 1 by 2, that will be 5. So if you simplify, what we get? So a of n equal to 2 into h of 5 minus n, we get it. So now we need to substitute 1, 2, 3, 4, 5. So I am going to find one value. So a of 1 equal to 2 into h of 5 minus, instead of n I need to substitute 1. So 2 into h of 5 minus 1, that will be equal to 2 into h of 4. So this is equal to 0.6366. Now I am going to find a of 2. So instead of n we need to substitute 2 here. So 2 into h of 5 minus n. So n is 2. So 2 into h of 5 minus 2. So 2 into h of 5 by 5 minus 2. 5 minus 2 is 3. So 2 into h of 3. So look at the h of 3 value, that will be 0. So 2 into 0 will be 0 only. Now look at this for a of 3. So a of 3 equal to 2 into h of 5 minus 3. So 5 minus 3 is 2. So we need to take h of 2. So 2 into h of 2, look at the value. H of 2 equal to h of 8 equal to minus 0.106. So multiply with 2, we get minus 0.212. Similarly, find for a of 4. So 2 into h of 5 minus 4. So 2 into h of 1. So that value will be 0. And a of 5, so that will be equal to 2 into h of 5 minus 5. So 5 minus 5 is 0. So 2 into h of 0, that is equal to 0.127. Now I can write the expression h of e power j omega, that will be equal to 0.5 plus 0.6366 into cos omega, because look at this. A of 1 we have the value. So I am taking this value with the cos of, look at this, cos omega n. So if I have omega equal to 1, we get a cos n. So that's why I am getting this is a 0.6366, this is a coefficient, and cos omega. Look at this a of 2, this value will be 0, so we can skip it. Look at this a of 3, we have the value minus 0.212. So we need to substitute this minus 0.212 value, cos of, look at this, we have the value as n omega. So n is 3 here, so I am substituting as 3 omega. Similarly, a of 4, that will be 0, we can skip it. A of 5, we have the value, so we need to take this value 0.127 into cos of, the n value is 5. So I am taking this cos of 5 omega. Now we need to find this value for a complete 180 degrees. So we need to take the value, find the expression, and then we need to convert in terms of dBs. So first we take this omega in degrees. So I take this increment of 10 degrees. So I need to take from 0 to 180. I am going to increment from 10. So 0, 10, 20, 30 up to I am incrementing as a 180 degree. Second thing, we need to find this h bar of e power j omega using this expression. Also this value should be converted into a dBs. So for that we have another formula. That formula is, look at this, h of e power j omega in of dB will be equal to 20 log of this final answer. Again, this final answer we need to take a modulus, because if you take a logarithm of minus value, it becomes infinity. So whatever we are getting the value, we need to take a modulus. After that we need to take a logarithm, and then after that we need to multiply with 20. Now we can find it value. So take this, first omega is 0. So substitute here. So here there is a no omega, skip it. So here we have cos omega. So we need to substitute cos 0. And then here also we have cos 3 into omega. So cos 3 into 0. Here also we have this omega value. So cos of 5 into 0. So 5 into 0 will be 0. So here also we get a cos 0. Here also 3 into 0. This is also we get a cos 0. Here also cos 0. So cos 0 value will be 1. So 0.5 plus 0.6366 into 1 minus 0.212 into 1 plus 0.127 into 1. So we need to summation this value. So this is h bar of e power j omega. Now we need to take a modulus of this value and we need to take a logarithm. After taking logarithm, it should be multiplied with 20. That value only plotted here, put it here. This is 0.4 because this is a h of e power j omega in terms of dB. Now we can substitute the value for the remaining, so 10 degree, 20 degree, 30 degree. Similarly, we can substitute it for all 180 degree and then we can take these values. So once if we find out this value, we can plot this. Look at this. So 0 to pi I am taking this. Look at the h bar of e power j omega in terms of dB. I am going to plot it. So up to this 0.5 it becomes value from 0 to minus 70. Again it increasing. Again it will have a decreasing and increasing. So this have a small oscillations. So this is an actual response from an FIR filter, and this is we have some oscillations due to this effect. Thank you.